Hey everyone, welcome back, and today let's solve Leetcode problem 2200 titled Find All K-Distant Indices in an Array. So we're given a 0-index integer array nums and two integers key and k, and a k-distant index is an index I of nums for which there exists at least one index j such that the absolute value difference between the two indices is less than k and nums at j is equal to key, which really this just tells us that there has to be two indices in the input array nums that are within k apart, where one value is equal to our input key. And we want to return a list of all the k-distant indices, but in this case, sorted in increasing order. So let's go ahead and gloss over the examples here. In example 1, we have our input array nums to be the following. Our key is 9 and k is equal to 1, meaning we want the absolute value difference between the two indices where one of them is equal to key or 9 to be 1, right? In this case, there are 6 different indices that kind of have that pattern, which would be 1, 2, 3, 4, 5, 6, or basically just 3 pairs of indices that really form that pattern, right? And in this case, 1, 2, 3, 4, 5, 6 would be in sorted increasing order, and these would represent the indices I and j, where for all these indices I and j for the specific pairs, nums at I and nums at j, their actual value difference between I and j is less than or equal to 1 or k, and one of those values is indeed equal to 9, as we see the two 9s here. So in example 2, we have input array nums to be 5 2s. The key is also 2 and k is also 2, and in this case there are actually 5 different kind of indices, which would just be every single index in the input array nums. Why? Because every index is the key of 2 and k is equal to 2. And so again, for all the indices I, there is going to be some j where it's equal to 2, and so since every value is equal to the key, every index is a k-distant index, and so we return all the indices in the input array nums. So for the constraints here, we see that the length of input array nums is going to be between 1 and 1000, kind of telling us that this isn't, we don't have the largest of inputs, so we don't have to have the most efficient of solutions, and any value in the input array nums is going to be between 1 and 1000, where the key is going to be an integer from the input array nums, and the value k is always guaranteed to be between 1 and the length of our input array nums, right? Kind of just confirming what the problem statement said and guaranteeing that we're always going to have valid inputs. Which brings us to the main kind of approach that we need to take to solve this problem. And that really is, it's a very straightforward simulation problem, where really we have to really care about where in one pair, at least one value has to be the key. So basically we just iterate over every value in the input array nums, and as long as we find a value that is a key, that can be our j value, and we just have to kind of explore its bounds, meaning all the other indices of that j value that are k less or k greater than it to be a potential I value that actually are valid in the range of the length of our input array nums, adding them to a list that we finally sort before returning, right? So that's going to be it for the kind of way we solve the problem. So let's get into the actual coding solution, right? So the first thing that we're going to do is just get the length of our input array nums and store it in n, really just to help us iterate over the input array nums later on, and also check for indices in bounds of the input array nums so that we don't get an index out of bounds error when we're checking for our potential I index values once we find our j values that are actually equal to our key, right? Now let's also initialize a result to be an empty set. It's going to be initially a set when we actually add elements to it, and we'll turn it into a list once we actually kind of sort it and return that final result, right? And the whole point of this result is really just to store the indices in, again, that sorted increasing order that we'll handle at the end of all indices that have that pattern of being k-distant, right? So now let's actually begin iterating over the input array nums, and we're going to actually enumerate over it because we also care about the index along with the value for every value and index in the input array nums. So for every index I and value val in the enumerate of our input array nums here, if the current value is actually equal to key, that means it is a potential j value, and so if that's the case, we'll go over all the potential I values from this index of the key val, or from this index of val of k to the right or k to the left. But we also have to handle the edge case of going out of bounds for all these kind of potential I values from this index I, right? So for all the j values in the range, now we have to be careful about, again, handling the case of going out of bounds, of having either negative indices or indices more greater than the number of elements that we actually have, right? So we'll go from the max of 0 and I minus k. I minus k is the k previous elements from the current index I or the current value key, and then we'll take the max of 0, because if this is negative, we'll just go up until index 0, still maintaining the distance to be k less than k away, and very similarly till the minimum of n, which is the number of elements we have, or I plus k, and we also have to do plus 1 to handle that kind of 0 indexed factor. So if we go, if this value is above n, we'll just limit ourselves to n, so we only go up until the number of elements we have, and we don't get an index out of bounds error. So for every potential I value, or rather j value, in this range, we'll just add to our result, or result.add j, very simply. And finally, return the result once we have all the values that are still k apart, within k apart, and where one of the values val is equal to key. And of course we have to also return it in the sorted form, which turns it into a list as well, right? So unless I made any syntax errors here, there should be accepted and there should be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. So for the memory complexity here, really just straightforward, big O of n, because we do indeed have one iteration of the result, which at worst case could store all n elements in the input array nums if all of them are key distant, like k distant, like we saw in example 2. And so it is going to be big O of n for the result. And for the runtime complexity here, it's actually going to be big O of n log n. The reason why is because although we really only have one iteration here in the input array nums, we are technically also sorting the result. And so if the result has all the indices from the input array nums, since we actually sort it, that is a big O of n log n operation. So that's going to be the runtime complexity of this solution. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.